Should we start? Okay. We have a lot to show, so let's get started. My name is Yushen Wen, and I have Ganesh Srinivasan here with me. I think most of you probably have heard of Ganesh before. We are both program managers with Windows Azure networking team. And today, for this session, we're going to talk about hybrid network offerings in Windows Azure. So this is the agenda for the day. So I'm going to spend a little bit of time just kind of give you a very brief overview of Azure, Azure Virtual Network, and also Echo. And then we'll dive down into the hybrid offering. So we have point-to-site, which we just announced last April. And then we also have site-to-site enhancement. And Ganesh will be talking about a lot of exciting new VPN vendor partnership that we're going to establish and what we have established over the last year or so. And then he'll be closing the session with a whole bunch of hybrid scenarios that you can do, the cool things you can do with Windows Azure Virtual Network. So before we actually start, I want to take a show of hand here. How many of you are familiar with Azure? Just kind of build a baseline here. Okay, good. So most of you are here because you know Azure. How about Azure Virtual Network and Infrastructure as a Service? How many of you are familiar with it? You use it? And how many of you are really not familiar with it? Just kind of, okay, cool. So just kind of spend a couple of minutes talking about Azure. So Windows Azure, of course, is the Microsoft Cloud Service Platform. And on top of Azure, we offer three types of services. We offer a platform as a service, where you can run web roles and the worker roles. And we have infrastructure as a service, which we just announced general availability in last April. I think it's April 16, where you can have virtual machines, virtual networks, and cross-premise connectivity. And on top of the PaaS and IaaS infrastructure, we also offer a value-added service, such as Azure Website or Azure Mobile Services. But for this particular talk, we're going to focus on infrastructure side of things. So we'll be focused more on PaaS, Platform as a Service, and IaaS. And the virtual network and the cross-premise connectivity apply to those as well. So the way to think about Azure Virtual Network is that it's really to let you, as a customer, extend your infrastructure to the cloud. So we like to call this the network on-ramp. For migrating your services that you run on-premise in your branches, you can migrate them to the cloud. And with cross-premise connectivity that we're showing in the picture here, you can actually build hybrid scenarios and applications here. Because let's face it, even though we are lifting and shifting a lot of the workload to the cloud, there are still stuff, either user data or either some infrastructure services that you would like to run on-premise. And virtual network with cross-premise connectivity enable you to build what we call the hybrid cloud or the hybrid applications, where you have your workload in the cloud and you also have your infrastructure. And they can communicate securely with each other. And we're going to be talking about the offerings that we have there. So Azure Virtual Network basically is an isolated entity that you can create and manage in Azure. So let's look at the next slide. Let's focus on the Azure Virtual Network a little bit. Just focus on the virtual network. So you can create subnets, specify your IP address, your private IP addresses you want to use in your Azure Virtual Networks. And you can bring your own DNS, specify your DNS that you run in Azure so that your on-premise or your Azure VM can all refer to your own DNS server. So virtual networks gives you persistent and stable IP address allocation. This is actually very important here because in order to run application seamlessly between your premise and the cloud, the IP address cannot overlap. And the Azure Virtual Network actually lets you specify multiple subnets that you want to use in cloud. But we do have the constraint that it has to be the private IP address space that you use in Azure. And on the premise side, you can either use your own private IP address space that you currently have, or you can specify your public IP address if you are using those on premise. So the virtual network is really isolated and secure in Azure. And by that, we mean you run your VMs in Azure Virtual Network. The VMs can only talk to other VMs in the same virtual network. Even the same customer like you can create multiple virtual networks. Within Azure, they are actually treated completely isolated from each other. So you have to connect outside back to the prem and connect back to your VM. And we did hear a lot of feedback talking about whether we can enable cross VNet communication within the same subscription. So these feedback we are actually taking within the team, and we're working on those feedback as well. So once you create an Azure virtual network, it is secure by default. You control what you want to expose to the internet from Azure. So the cross-premise connectivity is actually through the backend, through the VPN server. So those are secure. Kind of let you extend your trust parameters or boundaries from your on-premise through the VPN connections to the cloud. But from the cloud to the outside, you have to specify, explicitly tell us what you want to open and how you want to open it. Otherwise, it is completely closed by default. And the way we allow you to specify what you can expose is through public endpoint. And we're actually talking about public endpoint and how you can use ACL to specify, to actually limit the access to those public endpoints. So we've been talking about ACLs for a while. And this is just a very simple slide showing how ACLs in action. Without ACL, you specify the input endpoint, the public endpoint you want to expose. And we'll show an example just in a minute. You say, I want to, for this particular subscription, particular cloud service, I want to open TCP port 80 or TCP port 443. Once you create a public endpoint, anyone on the internet can access the public endpoint. There will be no blocking unless you set up something on the VM to block. With ACL, you get to specify who gets to talk through the public endpoint. And that's what we're going to show here. So you can see without the ACL, basically, anybody can talk to a particular virtual machines or particular cloud services. And then through the combination of endpoints and ACL, you get to specify not only what you open, but who can talk through those endpoints. So just as a very simple demonstration here, just a very simple diagram, you can see that we're allowing the prefix of 128, 250, and also 101, 102 to go through, but then we're blocking everything else. So this is just additional layer of the security in the infrastructure that we're bringing up to Azure. So let's look at how this works. Okay, so what you see here is that this is the very familiar Azure portal. Once you log into Azure portal, this is what you see. Basically, a list of resources or services you have created and you are managing in Azure. And for most of this talk, we're going to focus on the networking pane. So we'll go into network, create point-to-site, create site-to-site, and stuff like that. But for the ACL demo, we're going to go to the virtual machine. Right? So for the ACL demo, we have created a test VM2, and we have an IaaS, have a web server running on the test VM2. And you can see that there is a DNS server associated with it. I'm just going to click copy and just show you. It's a very simple website that we're running. So right now, this is actually accessing the particular services you are running in Azure from this particular demo laptop. So we have a 10. Address assigned by the conference network, and we can access the website. So if you click on the test VM2, let's look slightly more detail of this particular VM. So this is the dashboard of the VM. And there are a lot of information that you can get from looking at the dashboard. So let's just kind of take a quick look. So you can see the status, the VM is running, and there's a DNS name associated with it. And also you can see the public IP address that we are exposing for this particular VM, and I'll show you how. Sorry, let me just log in a little. And also the internal IP addresses that we're using internally in the Azure infrastructure, all the information that you can get here. And in order to open up a web, the web port, TCP port 80, you need to go to the endpoint side of things. So this screen shows all the endpoints that we have specified for this particular VM and for this particular cloud service. And you can see that we have PowerShell, remote desktop, and in particular, the third one, the web endpoint, is what we create. So this one shows that we are opening up TCP port 80 on the internet side. That's why from this particular laptop, I can actually access the web server running in Azure. So we're going to demonstrate how you can configure an ACL to block access for everyone except the certain IP address or prefixes that you allow to access this web service. So we're going to do this through PowerShell because there are a couple of issues we're still working through with the fit and finishes of the Echo feature. So the portal will be coming online shortly. And to manage Windows Azure, let me just take a brief moment. So you've seen the portal. You can do pretty much everything you want to do from the portal. And then you can also use PowerShell to write script to manage your subscription. And in this particular case, we'll be setting endpoint echo, and we'll also be configuring the load balance endpoint just kind of together to show you how this works. And underneath, both from the portal and also from the PowerShell, it's actually all calling into the same set of REST API on the platform. So that's why they really are functionally equivalent to each other. And if you really want, you can also program directly to the REST API with the right credentials and such. So in order to use Azure PowerShell, just for those of you who are not familiar, you actually need to go to the Azure website and you download the Azure SDK. Once you install the SDK, then things become very straightforward. So let's just look briefly at this couple of lines. So the first line is basically just import the Azure commandlet module. And then once you do that, you also need to specify your credential. So the fourth line, the import publish setting file, this particular file consists of all the directories to the certificate and all the credentials information. So if you want to look, you can actually look there. So once you import both, you need to select subscription. So the next two lines basically select the subscription under this account that you want to apply this particular PowerShell script to. So that's just kind of setting up in the background. And then you can see from this line forward, from line number 9, so we created echo set. Right? So this is a new commandlet we're introducing to the Azure PowerShell set. So what we are doing is very simple here. We create an echo set, and then we add a rule with this particular line, set Azure echo config into this echo set. And then the third line is we apply this echo set onto the load balance endpoint. So really, it's just as simple as that. So let's look at this line. You set Azure echo config. We have the usual permit and deny rules, and this is 45 tuple, right? So this is TCP port 80, UDP port something that you want to allow or deny. And of course, we let you specify the order you want to apply the rule, because just like firewall rule, order is very important. I want to allow certain IP addresses through, and then I want to deny something else. So you need to, if you have a blanket rule such as deny all or deny an entire subnet, you do want to poke a couple of holes to allow the certain access that you want to allow. And the remote subnet basically specify what's the remote address you want to apply this echo rule on. I want to, in this particular case, you can see that we have 131.107.64.112/32. So we're using the typical CIDR rule, CIDR notation here. So you can specify a subnet of /A/16 larger subnet, or in this particular case, we actually do /32, which means an individual IP address. So you're down to, you have all the granularities that you need. And a simple description. And finally, you say, I want to apply the echo, I want to add this particular rule into the echo set. And the next line is also very straightforward. Basically, we create a set of echoes, but you need to specify which endpoint you want to apply this echo to. So this is just the typical set Azure load balance endpoint, because as you just saw, we created one for TCP port 80. So you specify the service name, the load balancer set names. This is the web port 80. And protocol TCP or UDP and local port. And then you assign the port echo rule here, right? So once you set that, the next line basically just dump everything just to see that we actually apply the rule, just kind of show what the rule looks like. So let me run the script here now. So what I'm doing right now is also that I'm actually running the PowerShell script locally on this demo laptop, and this is talking through the conference network to the internet back to the Azure portal. So we are actually doing this live, so let's hope this works. And at the same time, what this rule does is that we open up the access to a particular IP address. And some of you might ask, then what about the others? I mean, we only specify allow one. So the way Azure Echo and also what we do in general is that unless you explicitly open something, we close everything by default. So sure, you can add a deny all rule if that makes you feel better. But in this particular case, by adding a single allow rule, we open up one IP address to access the web server, and we deny everything else by default. So that's why you only see one rule. Okay, let's see if this is, oh, okay. So it's actually still setting it. So now this is done, succeeded. Oops. Ah, okay. So you can see that, yeah, thanks to Ganesh. You can see he set up this whole demo. So what you are seeing here is that that particular command simply lists all the load balance endpoint. We have 3, so you will see 3 blocks here. And on the last one, the web 80, you see there's no echo for the others, but we apply a my-dtab echo, which is actually matches the name here, which means in this particular load balance endpoint, we have this echo apply. So to show that it's actually taking effect, so I'm going to close this one. Now I'm going to clean the cache, Control-Shift, delete. This will take a little bit. Okay. And then I'm going to open a tab again and see if we can access. So if the echo rule has taken into effect, then what this would do is we're going to be waiting here for some time, and we won't be able to access the web page. To show that we can actually still access the web page by the address that we allow. So you can see it's actually defaulting to the Bing web search. Good. So here, this is, let me see if I can show the IP address here. I don't know if you can see that here, but, oh, this I cannot zoom. So you see this is 131.107.64.111 that I'm highlighting there. Matches exactly 131.107.64.111 here. So let's, from the browser, see if we can just. So I can still access the web page from this one. So I mean, I can do the delete cache again, but so you get the idea. So this is our echo, and just very briefly, in order to reset this echo back, you just simply comment this line out. You say just comment this line out, and you run this script again. This would actually reset the echo back. Because right now we are actually creating an empty echo set, and again apply once again to the load balance endpoint. So I'm just showing a very simple one-line rule, as in we're going to permit something, and then we're going to deny everything else. Okay? So that's the part of echo that we want to show. So let's go back to the deck. So then we really are going to get into hybrid networking. So I think this is also a familiar slide. This just shows that we have a lot of options at different layers. From the application layer, you have SQL data sync, you have service bus that you can use to exchange information between your on-premise servers and your Azure workload. And then we have secure machine-to-site, secure machine-to-machine connectivity, which is known as Windows Azure Connect, which we're going to retire in July 3rd. So at July 3rd, we're going to just cut off the service. So if you're still using Windows Azure Connect, so please come talk to Ganesh or I as soon as possible. We'll show you. To fill the scenario gap, we introduced the Azure point-to-site VPN connectivity into virtual network. And just a little bit about why we actually made the decision, because lots of people ask about that. So as you can see, virtual network really is the foundation for us to build the hybrid applications and scenarios. And Azure Connect, as it was built and implemented, was actually not compatible with virtual network, and it was running on a totally different separate infrastructure. So we had to make a hard choice to deprecate Connect and we introduce a point-to-site VPN, which you can actually use with your virtual network together with site-to-site VPN, as we will show you. So for this part, I'm going to focus on point-to-site connectivity. So once again, very familiar picture. You have Windows Azure Virtual Network you create and you're managing, and you connect your virtual network through the site-to-site VPN to your on-premise data center or your own private cloud. Point-to-site VPN actually enables new scenario here. You have remote workers actually have laptops just like this one, and then you can actually VPN into your Azure virtual network without going through your premise. So that's the point-to-site VPN. And the cool thing about the point-to-site connectivity is that literally you can connect from anywhere. The demo we're going to show is actually, once again, from the demo laptop here, from the local convention center network, we're going to connect to our Azure virtual network to showcase point-to-site. The underlying protocol is SSTP, Secure Socket Tunneling Protocol, which is also a standard VPN protocol. It is basically running over TCP port 443. That is why point-to-site, you can actually connect from anywhere, either your home, behind your home router, behind if you are in a coffee shop, in an airport, or like we are right now in a conference center, that you can connect directly from your machine to your Azure virtual network. And it is very easy to set up, as we will show. Another important thing to note about point-to-site that is different from Azure Connect is that we are not installing any software running on the machine. So Azure Connect actually have a process constantly running on your local machine and when you are connecting. So it's actually processing the network in real time and such. The point-to-site VPN, we are using Windows inbox VPN client functionality. So this is Windows 7, Windows 8, Server 2008 R2, and Server 2012. So the application installation basically boils down to installing a client certificate and then installing a VPN profile configuration. So you just configure a VPN interface on your laptop, point to the Azure side of the VPN server, and that's basically it. And this is the primary connectivity mechanism we're targeting for the dev test scenario. So you can imagine as a developer, you can sit in a coffee shop and doing sort of prototyping, debugging, and coding, or do whatever you want. Or as we are doing right now, showing demo in a conference. And another important point to note is that, just look at this previous picture. It is coexisting with site-to-site. So you create an Azure virtual network, you create a VPN gateway, you get both site-to-site and point-to-site. So this is continuing our theme, kind of the power of and. So you get both together. So here I'm just going to do a very quick advertisement for Ganesh. Ganesh has another session which it's focusing a lot about dev test scenario. So he will be talking about all the cool things that we are actually doing to enable developers and testers to utilize Azure. I think the good thing here is that point-to-site, why is that particularly suited for this one? Because it's very easy to set up and get going, and you only pay what you use. And of course, Azure as a cloud allow you to use existing development tools and also the languages that you are familiar with. And virtual network is a perfect mechanism for you to set up a secure sandbox in minutes rather than buying machines, setting up your labs and such. That could take days. And of course, you can access on-prem resource if necessary. Right? So the picture here just shows that you can see on the right-hand corner, you have developers using point-to-site, Visual Studio, or building your own applications. And at the same time, site-to-site allow you to set up the access if you need to access your on-prem infrastructure servers. So once again, very familiar slides, but we added a little bit to showcase what's the difference between the Azure Virtual Network site-to-site and point-to-site. So I'm just going to run through this very quickly. So from your network admin, you can set up your Azure Virtual Network, specify your on-premise site. In the network configuration schema, one thing you notice is that with point-to-site, we added a new element called VPN client address pool. If you're using Portal, you don't need to worry about that, but you are looking at the schema, this is what you will see, where you can specify the VPN client addresses you will be using to connect to your virtual network. Because this is network communication, we actually need to get a non-colliding address block from you. And of course, you download the VPN device configuration script, and then you can set up the site-to-site connectivity. Now, once you create the virtual network gateway, so let's deploy the package first. Once you create the virtual network gateway, what you need to do to enable point-to-site is that you need to upload a root certificate to Azure. The reason we need to do this is because we are using certificate to authenticate who can connect to your virtual network. So the flow is you or your IT admin actually need to create a root cert, upload only the public key of the root certificate to Azure, and we will, based on the root certificate, authenticate any client connect to Azure. And on your side, you then create and sign client certificate using the same root cert, and those you distribute to your employees or to your internal or even external customer you want to allow access to your virtual network. And once you do that, only after you do that, then we actually will show a link to allow you to download the VPN, what I call VPN profile configuration tool. And then in the demo, we'll show you the experience of actually going through those steps. So let's take a quick look at that. So once again, we are showing the Azure portal, and now we have switched over to the networking pane. So what I'm going to do now is I'm going to walk through the wizard experience of creating a point-to-site and point out what you need to know there. So let's say create a new network. Let's use custom create, right? So let's say TechEd demo. I'm going to create a new affinity group just like before. Let's say East Asia. Demo AG. And once again, this is part of the virtual network, so you can do your bring your own DNS. So the cool thing here is that before you only have site-to-site. Now you can do site-to-site, point-to-site, either one of them. And the graphic shows which options you are selecting right now. So let's just do site-to-site for point-to-site for now. Like I said, because this page asks you to specify the addresses you want your mobile client or remote client to use, which cannot collide with whatever you already specified for your virtual network, because the same IP address, we don't know how to route the packet. Actually, it'll fail if you actually do that through Portal. So let's actually pick a different one. And then, as before, we ask you, what's your address space for the virtual network that you have, private address space. So let's just go with the default. And let's just do /24. And then a couple of enhancements the Portal team made is that we actually created an add gateway subnet button, because before that's kind of the confusion. Once you have gateway, we actually need to allocate a very small subnet. As you can see, this is a /29, about 4 or 5 addresses out of the 8 addresses. So that's it. This is the minimum virtual network you can create. So you just hit create, and the network will be creating right now. This is probably take a minute or two. So let's go to one of those that we actually created for this demo. So in this particular case, we actually select both. So we have site-to-site and point-to-site, and you can see site-to-site is actually working right now, and point-to-site right now, we don't have any client connecting to that. So I want to call your attention to a couple of links that on the right-hand side. So you can see that there is an upload client certificate. This is actually upload your root certificate, so the public key portion of the root certificate. So once you create the gateway, after you created the gateway, then you click on this button. It's basically a pop-up window to ask you to actually browse for the certificate file. Oops, let me just close that. And then after you upload the certificate, what we do is we actually generate dynamically the VPN installation package based on the certificate you created. You uploaded. So you can say, I'm going to download the AMD64 client package, or if you have an older laptop running x86. So you can do that. And once you click on that, it's actually going to show, below it's actually working. So let me just kind of shrink this a little bit. Yeah, it's trying to, and then you can see it's actually showing, okay, now you can download the package to install. So I'm not going to download that right now. So let's just go to the one that we created before. And before we show any of that, the most cumbersome step for setting up point-to-site turned out to be how you create and manage your certificate. So we just want to take a brief moment. This is actually on this particular laptop running Windows 8. You just need to go to the Microsoft website, download the Windows SDK, and this is Mixer. So once you install SDK, this is actually inbox, right? So you can use this, and we have all the instruction on the MSDN website. So as you can see here, we have created a certificate here. We have the client cert and we have the root cert, and we downloaded the installation package. The name of the package matches your name of the virtual network. To install the certificate, you simply double-click, and then just all the default settings that there is, right? And you type the password. And that's it. So I know in the instruction we actually go through the cert manager screens and such, but you just need to double-click. And we have already installed the point-to-site client. Once you install, it's actually, that's what we mean by this is actually Windows inbox client functionality. As in, you see, it just show up here, this particular one, TechEd Brooklyn Light. And connect is as simple as right-click and just say connect. And that's it. Now we are actually connected. You can see it's actually connected. And to show we are actually connected, I'm going to TS into the VM that we set up as part of the, actually the next demo or the demo for tomorrow. And notice the address that I'm using to connect is actually a private IP address. This is 10.0.0.4. Right? So now I'm actually TS into my VM running in Azure. To show we are actually doing that, I'm going to right-click. I'm actually going to share this folder real time. Specific people, let's say everybody. Oops. Share. And from here, I'm going to do this. 10.0.0.4. It's going to ask the oh, actually, I didn't know we have more than one folder share. So you can see that now I'm actually from the demo laptop. I have direct access once I connect it to the point-to-site connectivity. And just to show this actually is live, I'm going to just copy a simple file here, and then it should pop up right there. So this is basically enabling you. You can imagine you're sitting here in the conference room. Instead of me doing this very simple and very kind of stupid demo, you can actually start debugging or developing your Azure stuff. And that's all I'm going to show for the point-to-site demo. Let me just clean this up a little bit and get back to the web page. And with this, I'm going to hand the session over to Ganesh. So now you have the real start talking about the site-to-site enhancement.
Thanks, Yushin. Hey, everyone. My name is Ganesh Srinivasan. I'm a program manager in the Azure networking team. We both work in the same team. I've been working on virtual networks for the past 2 years, and I focused primarily on the site-to-site side of things so far. So I'll give you an overview of what we've released so far in terms of general availability, what you can do with what we've released so far, and a couple of exciting announcements to share in terms of the VPN devices that we are announcing in terms of what we plan to support. In addition to that, I'm going to show you a few cool demos that our partners here have helped us set up. So it's going to be exciting. So if you were at TechEd last year, that's where we actually announced infrastructure as a service in preview. And virtual networks was part of our infrastructure as a service. Initially, we started off calling our infrastructure services just virtual machines. And then we realized that virtual machines could not stand on their own leg by themselves. And we needed to actually have a network to complement all the investments made in terms of, to realize what we put into virtual machines. And that's where virtual networks came in. As Yushin talked about earlier, virtual networks gives you a platform on which you can build applications on. and it gives you an extra layer of security, a secure boundary within which you can deploy all your services and share resources across them. There are a lot of cool things you can do with them, and we truly view them as the on-ramp to essentially enabling applications to be migrated from the premises to the cloud. You could do a lot of things. You could just lift and shift applications from your premises and run them in the cloud, or choose to move them in phases. And this is the technology that's going to enable you to do it, because it gives you this connectivity back to your premises. So the simplest thing that you could do, which is not very realistic in most enterprise class applications, is that you could lift and shift the whole application. That's really the ultimate goal of what we want everyone else to do from an Azure's perspective, and that's what we are focusing on, so that you can run all your IT operations from the cloud without having to depend on anything on premises. But that's something that we're going to realize probably a decade from now or even later. But till then, services that are running in the cloud will, in most cases, rely on something that's deployed on premises. So we offer this connectivity between the premises and the cloud through a secure IPsec tunnel. You have full IP-level connectivity between your corporate network or your office's network and the virtual network that you've set up in the cloud. So you could have any kind of traffic flowing between them. There are a few exceptions, though. We do not allow multicast or broadcast traffic or any encapsulated traffic to flow over this network. So other than that, most traffic cases, most applications that you run typically don't use that. So you should be able to basically run your applications in the cloud and still use, let's say, your Active Directory for identity or your SCOM service for monitoring the services that you're running in the cloud without having to do anything fancy. You just set up a virtual network in Azure, connect it to your premises using a site-to-site VPN, and you have the two networks now looking as one single network. So you can basically share resources across them. So when we started off planning infrastructure as a service, the one thing we realized was that any large-scale application relies on identity, and Active Directory seemed to be the glue of a lot of these applications. So if we made Active Directory work in Azure, most of our problems would become easy. Now, for us to be able to run Active Directory on Azure, we need to be able to run a domain controller, a DNS server in Azure, which means we need IP address persistence. So with virtual networks, one key thing we did was, across service heals, across reboots, across updates, the IP address we assign for a virtual machine stays with the virtual machine for its lifetime. We offer it kind of an infinite DHCP lease so that the IP address stays with the virtual machine. Now, a lot of people, when they're used to setting up domain controllers, may wonder, hey, look, the instruction says I have to have a static IP address assigned to that adapter, and then I can deploy my domain controller. But in Azure, we are making an exception for that. Even if you have a DHCP-based IP address, we know the fact that the DHCP lease is infinite, so the IP address will not change on you. So you could, with confidence, deploy a domain controller in Windows Azure. And that basically enables you to do a lot of things. Now, people look at Azure for a lot of things. People look at Azure for running SharePoint forms, for running SQL databases as shared databases in Azure. They primarily choose to do this because we also have another offering called Windows Azure SQL Databases. That's a service that we run, database as a service. It is not fully featured as what an on-prem SQL Server box gives you. And if you're used to using SQL Server, the box, and you want to just use it in Windows Azure, we allow you to run them as virtual machines in Windows Azure. Now, one new thing that you will see a lot of talks around this TechEd would be the fact that you can now do a SQL HA cluster in Windows Azure. So you could actually set up two SQL servers with another server for quorum and basically create a cluster of them and run SQL HA on them. The other cool thing you could do is the fact that one of those SQL servers could actually be on premises, and the other SQL server could be in the cloud. So your cluster could span your premises and the cloud. And the virtual network provides you the bridge between that. And typically when you do anything like this, you do take a dependency on a domain controller. Now, I didn't talk about one cool benefit of virtual networks. The cool thing that virtual networks does, which vanilla Azure without virtual networks does not do, is the fact that the trust boundary is limited to what we call as a cloud service in vanilla Azure. When you include virtual networks, we actually expand that trust boundary. So any service you put within the virtual network can talk to one another. So if you wanted your domain controller, which is deployed as a separate service, to talk to your SQL server, which is deployed as a separate service, you could do that and still have private IP level connectivity between the two services. So that's really important because this enables you to use SQL Server and build an application that uses a shared storage. You could have multiple front-end services that use the same SQL Server backend. The other thing, when we started off with infrastructure as a service, we had to pick something as a goal for us to support, which meant we were ready to ship. And we picked SharePoint for that because SharePoint, there was a lot of demand from customers saying SharePoint is something they want to run in Azure or in the cloud because they want to do collaboration and do a lot of these things in the cloud. And SharePoint was a typical multi-tier application that conformed to most of the standards line of business applications that people typically deploy. It has a front end. It has a dependency on an Active Directory domain controller. It uses application servers as a middle tier. And it relies on SQL Server clusters for its backend. So pretty much all the demos you'll see me doing probably today and for the rest of the TechEd and a few other sessions on TechEd will be focused on SharePoint as a center of, as the tool to which we demonstrate what we can actually do in Windows Azure. So this feature has been around for about a year in preview, and as of April, we actually announced virtual networks as generally available. What generally available meant was that you get an SLA on the availability of our cross-prem connectivity solution, and you get full support from our CSS team. Now, what we've done since we announced support, general availability in April, one of it is, of course, point-to-site connectivity, which we have in preview right now. We hope to make it generally available in the next few months. In addition to that, we've actually introduced support for route-based virtual, VPN services. When we started off supporting site-to-site connectivity, we had originally limited support to policy-based VPNs, which actually restricted the number of VPN devices and the configurations that you could do on the VPN device. Now, if you had very complex connectivity requirements where you had multiple subnets on-prem talking to multiple subnets on the Azure side, the matrix of essays that you had to negotiate was extremely hard to manage and maintain. In such cases, having a route-based VPN actually simplifies your configuration. You just create a forwarding interface on your VPN device and actually forward any traffic destined to that application to that device, to that forwarding interface, and it forwards it to the other side. So it's as simple as that. And the number of security associations we generate are pretty limited. We just generate a pair for a tunnel instead of having a pair for every subnet pair that we have to communicate between. So it greatly simplifies the VPN configuration. And what it really does for us in the back end is that instead of having our own custom VPN implementation, we've actually moved to using standard Windows Server 2012 routing and remote access service as the VPN on the Azure side. So we actually run 2 VPN gateways as soft VPNs for each and every virtual network in Azure. And they're just vanilla RRAS servers that are configured to act as your site-to-site VPNs. So all the effort that the Windows team put into working on interop with other VPN devices, we just benefit from it. So that's what helped us do a lot of things. We moved. So since our end is running a Windows Server 2012, you could now run a soft VPN. A lot of people have this requirement that they want to run a soft VPN solution because investing on our hardware is something that they cannot do. So we said, we'll offer you a solution that is out-of-the-box Windows. All you need is a vanilla Windows Server 2012. You can download a PowerShell script from our Azure portal when you configure your virtual network. And when you run the PowerShell script, it configures RRAS on your Windows Server 2012 and also configures the tunnel for you. I will show you how it works. In addition to that, people wanted a stronger encryption scheme and a stronger security protocol to basically run their application. So we actually added IKE v2 for key exchange and AES 256 for crypto. This makes your tunnel really secure. So if you have compliance or regulatory requirements where your crypto has to be AES 256, we meet that requirement. And to add to the whole thing, we are actually happy to announce a lot of new VPN devices that you can now use with Azure. We started off last year in preview with just Cisco and Juniper. Now we have Cisco, F5, WatchGuard, and our own Windows Server 2012 that you can use and that we validated in working with all these partners. That said, since we've moved to industry standard route-based and policy-based VPN solutions, any standard VPN device should technically work with our solution. We are, continuing to work with other partners to add more VPN devices to the network. But, this just opens up the options for you. And just to show how really cool it is that I'm going to use F5 devices for my demo today and show you what other new benefits and capabilities that it exposes for the platform. So with that, I'm going to show you a series of demos, primarily around how we could use F5. We have people from F5 here who are nice enough to partner with us and help us set up some of the demos here. And they have a booth downstairs, and I'd ask you all to check it out, where you could actually see how this had been put together and what this means for your business or for your company. So I urge you to go down and take a look at what the F5 team has to offer. So with that, I'm going to jump into the demo. So one thing that a lot of people have asked us is, I need to build intranet-facing applications, but I want to run them in the cloud. There's one deficiency in our platform today that we are working really hard towards filling up, which is the support for internal load balancing, support for a private WIP that's exposed only to the intranet and not exposed to the public internet. Till that feature comes into production for us, you have another alternative solution that our partners are helping us enable today, which is using F5. To illustrate just that, I've actually set up 2 SharePoint farms. I've set up 2 highly available SharePoint farms where I have 2 front ends in each region. I've picked one SharePoint farm in US East and another SharePoint farm in US West. And I have a pair of front ends, a pair of SharePoint application servers, a SQL HA cluster, and a pair of domain controllers in each region. So each region by itself is highly available. And I've created a mirror of that in another site as well. Now, both these virtual networks that I have are actually connected to my premises using a site-to-site VPN. And this time, we've used the F5 big IP as the VPN device to showcase this. So one common question we get asked, when we talk about virtual networks is, what's your availability story? What do you do to make sure that it's always highly available on the Azure side as well as on the premises side? So on the Azure side, as I mentioned a few minutes back, we have a pair of RRAS servers that we run for every virtual network, and that's dedicated for you. So they are run in active passive configuration. So if we detect that one of the VPN devices actually failed because we are of some configuration issue, or whether we are updating the infrastructure on which one of the virtual machines is running on, we automatically fail over to the second RRAS server that was in standby. And this failover typically takes about 30 seconds on our side. But we had the ability to support only one VPN tunnel from Azure to the premises, which meant the single point of failure would be the VPN device on the premises. Now, the big IP in F5 has a cool solution where you can actually cluster F5 devices and run them in active standby mode. So you can actually fail over the device, and the passive device will actually reestablish the VPN tunnel with our VPN gateway. So you now have a highly available VPN solution on the premises side as well. So both sides are highly available and are fault tolerant. So I'll showcase that capability. In addition, we've also configured the F5 big IP to be a load balancer as well. And we've created a load balanced endpoint on the F5 that load balances between the 2 SharePoint farms. So we look at all these capabilities. Plus, just to complete what Yushin had started, Yushin had shown you a demo of point-to-site and site-to-site coexisting in the virtual network. I wanted to show you the fact that we set up an RRAS server and how easy it was for us to set up the RRAS server. So these are the things that I'm going to show in the next few minutes. So to showcase this demo, I've actually set up the on-prem to be my office in Redmond. So I actually have a DTAP, which is a direct connectivity to the internet, bypassing all the proxies sitting in my office. And I have a hypervisor running there on which I'm running all these VPN devices. F5's big IPs are VMs running on that device, and I also have RRAS running as a virtual machine in that. So I'm going to show you the rest of the demo, logging into the hypervisor that's running in my office. So this is the hypervisor that's actually running in my office. And as you can see, I have multiple big IP virtual machines that are running in my office. But before that, just to complete what Yushin started, we actually have an RRAS server. So if you actually log into the Windows Azure portal and look at your virtual networks, One of the things Yushin showed was that on the side, you have the ability to upload a certificate and download a VPN client. Just right next to that, you can actually download a VPN configuration script. So this gives you a template for any of the standard VPN devices you have, and you will soon see over the next day or two, see F5 and the other devices we talked about show up in this list. So you should be able to specify the version, and we typically give you a template for the VPN device script that you can customize. Pretty soon, in the next month or two, instead of that being just a template, we will pre-populate it with your configuration. So you can just take the PowerShell script and run it in your box, and it automatically configures the virtual network. So this is actually a PowerShell script that you can download directly from the Windows Azure portal. And all you have to do is replace certain parameters that we've actually identified. In this case, enter the VPN gateway IP address and the pre-shared key and a few other parameters. So you copy the script over to the routing and remote access service. Once you customize it and run, so for this demo to run, you don't even need routing and remote access service configured in your virtual machine. You just run it as a PowerShell script. And once you're done running this PowerShell script, you actually have RRAS configured. And in this case, this is the IP address of the VIP that I had established, and it will actually automatically force all the traffic back to the premises using this RRAS server. So when you actually look at the virtual network that Yushin was showing, since he'd pre-configured it, you would see the fact that the RRAS server is actually connected, and he connected the virtual network client as well. So you see that the client count is also increased. We support up to 256 VPN clients plus a site-to-site VPN tunnel to the virtual network today. Now let's go to the F5 part of the demo. I am in my hypervisor right now, and you can look at the fact that there are big IPs. So I've named them Big IP1, Big IP2, and Big IP3. Big IP1 and Big IP2 are my VPN devices that are configured in hot standby mode. And for the sake of the demo, I've actually configured my office to be a small network, and I have a test virtual machine running there. Now I have 2 ping sessions continuously going to each of the virtual networks just to make sure that you can see the fact that there is connectivity between them. I've picked 2 IP addresses in 2 different subnets. The 10.2 subnet is used for US East or US West, and 10.3 is used for US East. I can say that based on the latency I see in my ping. Since this is connected to my premises, which is in Redmond, I'd see about a 20-25 millisecond latency between our US West data center and Redmond, and about 70 to 80 millisecond latency between the US East data center and my office in Redmond. So I have 2 SharePoint farms in either of the locations, and if you look at my load balancer F5, I've actually created a virtual server for my SharePoint. I've assigned a 10.1.0.10 as my VIP that runs in my internal network that I could connect to if I wanted to talk to my SharePoint farm. So from my test machine, I'm actually going to open a browser. It's immediately asking for my credentials. So once I enter my credentials, it's actually finding the right front-end server, connecting to it, and connecting to my SharePoint farm that I've set up in my virtual network. So let's say one site goes down. I'm going to basically look at my pool, which has 4 front ends that are actually load balanced. And I'm going to basically disable my US East data center altogether from this. So I just have US West running, I should still be able to refresh and connect to that IP address and connect to my SharePoint farm without a problem. Again, I could do the same thing. I could disable my US West data center and go to US East, and you'd see that I would have connectivity. So even if an entire highly available SharePoint cluster goes down, I still have the option to have my application running because I have another DR site in which I have the SharePoint farm working without any problem. So I could refresh this page, and as you can see, it can connect to the other data center and refresh the page without any problem. So now, in case you have two devices right now on-prem, and one of the devices goes down, so So I'm logged into the two big IPs. If you look at it, big IP 1 is the active one, and big IP 2 is in standby mode. I can force my big IP 1 to go to standby, which means this is going to be going down, and you'll immediately see the fact that big IP 2, which was in standby, became inactive. So the VPN devices failed over near instantaneously on the premises side. And if you look at it, the tunnel would have gone down momentarily. It takes a couple of minutes for us to realize that the tunnel is down, and we immediately renegotiate the security association. So if we waited a few minutes, you will see with the fact that the tunnel renegotiates with the other VPN devices. It should be a couple of minutes, and that's the downtime you'd expect when a complete VPN device goes down. Instead of waiting hours for actually reconnecting to a new box, it takes a couple of minutes and you completely fail over the tunnel. So that's an exciting capability that we have. So if you want to view this offline, the F5 team here has put together a great video that talks through the exact same process, and you can actually look at it and share it with your team, and it's great video. So in summary, basically, we've introduced this new capability that enables you to extend your enterprise network into the cloud. It allows you to use your own IP address space to move your virtual, to basically extend your networks to the cloud and use for virtual machines and services that you run in the cloud. We offer an industry standard IPsec VPN solution that enables you to connect the virtual network in Azure to your premises. And we support both route-based and policy-based VPNs. So what's new is the fact that we've added Server 2012, and we've added Citrix F5 WatchGuard in addition to Cisco and Juniper today. So this is great. You have a list of VPN devices to pick from. Some of them are also security devices and load balancers. So you get to do a lot more than just have a VPN device that's connecting to us. We've introduced this point-to-site. One of the areas that our platform is focusing on is basically in enabling dev test scenarios. We want to make sure that Microsoft products work better together. So our System Center suite of tools work with all other Microsoft products such as SharePoint and SQL and so on. And so we wanted to simplify the connectivity experience and development experience for those kinds of scenarios. And in most cases, if you're building these applications, you want secure private connectivity to these virtual machines that are running in the cloud rather than have connectivity to the public internet. To simplify that case, we introduced the point-to-site solution. The point-to-site solution, our value prop was that you should be able to connect to it from anywhere, which meant we had to choose a protocol that traversed NATs and firewalls. So we picked SSTP as a protocol that Windows supports in box. We also did not want to be in the business of shipping code to you that we had to patch and maintain and upgrade constantly. So we chose to go with the inbox VPN client solution that's supported with Windows today. So you don't have to deploy any third-party software or any software that we ship to get this connectivity solution working for you. All it needs is we do a certificate-based authentication mechanism today. We are striving towards improving that and making it as simple and easy as possible. So the cert-based connectivity authentication works really great, and in a matter of seconds, you can have your machine connected to the virtual network in Azure. And ultimately, all these solutions make it extremely easy for you to start developing, and once you've developed a solution, move that solution to production and have that connectivity to your premises using a site-to-site VPN solution. So overall, from a connectivity perspective, we cover both aspects of an IT admin connecting from their premises to Azure using a site-to-site connection. And at the same time, we are simplifying the time it takes to establish connectivity and improve dev test scenarios. So since this point-to-site solution that Yushin spent a lot of time talking about is still in preview, we'd encourage you all to sign up for it. It's all enabled in all subscriptions that you have for Azure today. You can just try it out, and if you have any feedback or any questions, feel free to email that alias. Our team members would be more than happy to hear your feedback to help improve the product, and we'd also be able to answer any questions that you may have. In addition, we've actually released a lot of tutorials, and one of the key things we did in spring was completely overhaul our documentation to make it more usable and readable. So we've added tutorials that will enable you to walk through the process, click through it, and get this going in a matter of minutes. Once it works, we'd ask you to try out all your dev test scenarios in Azure. We have a whole lot of talks over the next few days highlighting various aspects. We're going to talk about what went into the platform. Mark Rusinovich is going to talk about that. We're going to have the SQL Server team talk about all the investments they made in enabling SQL Server and SQL Server HA running in Azure. We're going to talk about how SharePoint forms can be set up in Azure. We're going to talk about how you can use PowerShell to script the whole thing and get this going very easily in Windows Azure. So there are a whole lot of topics that we have. And I have another talk later tomorrow where I'm going to talk about how you can use all these technologies to realize dev test scenarios, where I'll showcase how you can build mixed mode applications where your front end are PaaS and your back end is a SQL Server database, how you can mix and match IIS and PaaS, how you can actually do load testing in SQL servers, how you can do a lot of other things to make the most out of the platform offerings that we have and minimize the time it takes for you to prototype, build, and test stuff. We also have a lot of online documentation that's all updated that talks about all the VPN devices, connectivity, tutorials, and it also has a frequently asked questions section that lists out the most commonly asked questions. If your questions are not answered there, feel free to send an email to this alias, and we'd be more than happy to answer your questions. And as I mentioned earlier, there are a whole lot of talks around this topic on Azure Infrastructure Services. There are about 8 talks on Azure Infrastructure Services in this conference, and we plan to cover every aspect of infrastructure as a service and hope to answer as many questions that you'd like to know. We also have a couple of demo booths downstairs where if you can't find us and ask questions right now, you can stop by and we'd be happy to answer your questions. So with that, I'd like to thank you all for showing up today and listening to us talk. Please, I urge you all to try these out and get back to us if you have any questions, and we'd be more than happy to answer them. Thank you. So we have about 10 minutes, and I'd be happy to take any questions you have. If you have any questions, you could get to the microphone that's been placed there and ask questions.
Is this on?
Yep.
Okay. So the ability to rebuild the tunnel that you've got in Azure looks pretty good, but I still don't see the reliability that I see currently in AWS, where in AWS you can build up 2 tunnels to 2 different egress points, because if the on-prem egress point goes down, I've got a failure of the entire network. And in AWS, you can build 2 sets of 2 tunnels, giving you 4. Mm-hmm. When am I going to see that kind of reliability in Azure?
So we evolve constantly. Our platform is evolving constantly. It's, we've moved to a shorter release cadence compared to what we used to be. So we are constantly releasing all these features in a shorter cadence. Hopefully this year you will see those kinds of capabilities show up in our platform closer to the end of the year.
I'm waiting for it because I want to build out an architecture, but I need the reliability.
Excellent.
Is this on?
Yep.
So can you elaborate on the 2012 RAS site-to-site kind of requirements, whether that needs like a public IP, can that be dual home to the DMZ, et cetera?
Yes. So you would need it could be a server or it could be a virtual machine that's running vanilla Windows Server 2012. You don't have to configure any special roles. This PowerShell script that we have configures the roles. It does need two interfaces, and one of the interfaces has to have a public IP address. And that public IP address should not be behind any NATs or firewalls. It has to be directly exposed to the internet. You would need a private interface that connects back to your network so that you can configure routes from any machine on-prem to the RAS server through that interface. So we don't have any specific requirements on hardware. If Windows Server 2012 can run on that hardware, you should be good. So any other questions? If not, thank you very much. We'll be around here and we'll be in the demo booths. You can stop by anytime and feel free to ask any questions you have. Thank you.